Welcome to Design and Analysis of Algorithms class. Today I am going to start another application on divide and conquer. So till now you have seen number of applications like chain matrix multiplication, knapsack problem, traveling salesperson problem, right? So this is another application on dynamic programming which is string editing, right? So in today's class I am going to cover what is meant by string editing, and also we will see an example how to find the edit distance between two strings, and coming to the objective. So with today's lecture the students are able to understand the concept of string editing. Now outcome. So the students are able to apply the string editing on a given strings using dynamic programming approach. So where exactly we are using the string editing concept in real world, right? So for suppose if you are typing a message, in your mobile phone, right? So like for example you are typing LI, right? You are typing LI. So you have typed LI. So immediately you are getting the options, like you are getting the dictionary options where you will get options like 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 or LITE light, right? So depending upon the context also you are getting the nearest words, right? You are getting the nearest words. For suppose here you have given LID you have given lid. So immediately it will give you lids also, right? So basing on the context it is giving you the corresponding words or corresponding strings, right? In computer science we will call it them as a strings, right? Corresponding strings. So autocorrect option is also there. For example, you are typing BEUTIFUL, right? So if you have typed like this and you have given a space, automatically it will be corrected as automatically it will be corrected as beautiful with the spelling correction also. So this is all we can done by means of string editing. So here what is the least possible distance to convert one string to another string? So basing on the minimal distance or minimal number of operations to convert one string into another string. For example here I have gate, goat. Okay. For example here I am having two words, gate and goat. So here I want to convert this. This is my x and this is my y. I want to convert this x to y. So what are the number of operations I can apply? So generally the operations I can apply on the strings are either I can insert a character or delete a character or transfer or change or replace, whatever, okay. Either I can insert a character or delete a character, I can replace a character, right. These are the three operations I have, right. So now here I want to convert this x to y. So here g and g, okay. So initially what I can do, I will see the first I will say the first option, which is, so let's see how to convert gate to goat, right. So gate to goat. So here this is my x string and this is my y string. So in order to convert one string to another string, there are three operations. First operation is insert, second one delete. Either I can insert a character or delete a character or replace a character, right. So now initially to convert this to this, what I will do is I will delete, okay, I will delete G character and I will delete A character, I will delete E and I will delete E. Okay, so let us consider to insert I require cost as 1 and to delete also I require cost as 1 and for replacement also I require the cost as 1. So here I am I am deleting G, I am deleting A and I am deleting E, right. So to delete the 4 characters I require cost as 4. So 4 operations, 4 delete operations, right. Now after that I am inserting G and I am inserting O and I am inserting A and I am inserting T to X, okay. So that 4 insert operations, right? So 4 delete operations and 4 insert operations together, which is equal to 8. This is case 1, right? Now coming to case 2. Case 2, what I'll do is, right? So G remains same, right? So G remains same, I'll not do anything, and now here I will insert O. I will insert O, and then ATR remains same, and after that I will delete E and I will insert T. Okay, here these 3 operations I will make. What are that? Inserting O, deleting E and inserting T. So what here how many number of operations I will be having? 3 operations. So these 3 are minimal number of operations. So here I require 8 operations to convert x to y, and here I require 3 operations to convert x to y. So here what is the minimum one? 3. So finally to edit string x to string y, that is to convert string s to string y, the number of edit operations are 3. The minimal number of edit operations required are 3. So this is what we want to find out with the help of dynamic programming approach, right? Now we'll see that. What is the problem statement? Here basically given 2 strings x and y, So x is equal to x1, x2, x3 and so on xn, and y is equal to y1, y2 and so on ym. So here the distance, the total size is n and the total size is m. Nothing but size or number of characters in the given string is, in the given string x is n and in this string is m, right? Now here x and yj are the members of or the characters of set of symbols known as alphabet, and where I is ranging from 1 to n and j is ranging from 1 to m. Why? Because here j corresponding to the index of y and I corresponding to the index of x. Now here what is our main theme? Main theme is to transform x to y, that is transform x to y using some sequence of operations on x. So what are the sequence of operations I can apply? Either insert a character or delete a character or replace a character, right? Now the edit operations are insert, delete or replace, and for performing the operations there is a cost associated with it. As already we have seen, for performing any operation there will be cost also associated with it. That is nothing but operational cost. Now, what is our objective? The problem of string editing is to identify a minimum number of operations, edit operations that are required to transform x to y. Here I want to transform or convert x to y. What are the minimum number of operations are required? This is the main objective behind string editing. Now these are the notations we are going to utilize under string editing concept. So d of xi. D of xi corresponding to cost of deleting a symbol xi from x, and I of yj corresponding to inserting of a symbol yj into x, inserting of a symbol yj into x. So I of yj, which means that insertion, so inserting, d means deletion. Now cost of xi comma yj, cost of xi comma yj is nothing but changing the symbol from xi to yj or replacing the symbol from xi to yj, and cost of I comma j is the minimum distance of any edit sequence for transforming of this xi to yj. So this is the final cost, and for this cost of ij I am going to write the recurrence relation, because this is a generalized cost which is the minimum cost required to transform x to y. Now this is my optimal solution, which is cost of n comma m. Cost of n comma m is the optimal sequence or optimal cost or the minimal number of operations required to transform x to y. So this is our final solution, which is cost of n comma m. Coming to the recurrence relation. So here if I is equal to j is equal to 0, then the corresponding cost is cost of I comma j is 0. Now if I is greater than 0 and j is equal to 0, which means that here the first string consisting of more number of characters, whereas the second string is a null string. So we can transform x to y. How I can transform? Here y is a null one, right? How I can transform? I have to delete the corresponding characters. If I am deleting the characters from x, then ultimately what I will be having? I will be having a null string, right? So in order to obtain that null string, what I am supposed to do? I have to apply the deletion operation. So here cost of I comma 0 is equal to cost of I minus 1 comma 0 plus d of xi, which is a deletion. Now if I is equal to 0, that is here the x is null and j is having something. Then in that case what I am supposed to do? I need to apply insertion. I have to insert the characters which are in the second string to, which are in the second string to x, right? So now we can transform x to y by a sequence of insertions. So to apply insertions, cost of 0 comma j is equal to cost of 0 comma j minus 1 plus I of yj. So here if I am having null in the first string, then I want to convert into y. Y is having something. So in that case I have to apply insertion. Whereas if I am having null string in the y and if I am having something in the x, so in that case I have to apply the deletion. Otherwise, if this is not the case, I is greater than 0 and j is greater than 0, in that case I am supposed to do replacement basing on the necessity, right? So now finally the recurrence relation for cost of I comma j is given as cost of I comma j is equal to 0 when I is equal to j is equal to 0. That is the base case. Now when j is equal to 0, that is second one is null and the first one is having something. So here I want to convert the given string into null string. So how can I convert? By applying deletions. So here d of xi, cost of I minus 1 comma 0 plus d of xi. Now if I am having the first string as null and the second string I am having something, so in that case I have to apply sequence of insertion operation. So I of ij plus cost of 0 comma I minus 1. If not, I is greater than 0, j is greater than 0. In that case what I am supposed to do? Cost complement of I comma j. So which is nothing but here cost complement of I comma j is equal to minimum of either this one or this one or this one. That is here cost of I minus 1 comma j plus d of xi, the same thing, and cost of I minus 1 comma j minus 1 plus c of xi yj. Here this is nothing but replacement, comma cost of I comma j minus 1 plus I of yj, which is nothing but insertion. So here either insertion or deletion or replacement. So which one is yielding the minimum? That one I am supposed to take it as this cost when I is greater than 0 and j is greater than 0, right? So for suppose if you have seen here, this is so here I am having a string called, g, right? And here I want to convert this g to null. Here I am having null, right? And here also I am having null. So here I want to convert this g to null. So g to null means what I am supposed to do? I have to apply the corresponding g to null. So I have to apply deletion operation. So applying deletion operation, here I will be getting 1, right? So here I am having GA and GA to null. GA to null means here GA to null. What it mean? Here I have to apply 2 deletion operations. So 1 plus 1, which is equal to 2. GA R to null. So here I have to apply 3 deletion operations. So 3. So likewise I need to fill this corresponding table, right? So now let's have a small example over here. I want to transform winter to writers. What I am supposed to do? Initially winter, right? So replace V with W. So now what happened? This is a string. Now here from this I am having this as the input. vintner. So for that insert R after W. So this will be the string, right? So likewise here I am applying some number of operations to convert this vintner to writers, right? So here this is vintner to writers. So initially I am replacing V with W and then insert R after W and then match I, delete N, match T, delete N, match E, match R and insert S. So here likewise I am applying number of operations, edit operations to convert this to this. So here how many operations I applied? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 operations I applied to transform this to. So now let's see another example which is come under our syllabus, right? Nothing but where we are using our recurrence relation, where we are using our dynamic programming approach, right? So this is our given string, this is our given string A, B, A, B, and this is our B, A, B, B. So here I want to convert this x to y, right? X to y. So here A, B, A, B. So what I am supposed to do? I have to delete A. Here I have to delete this A, deletion of A, and then have one more A, right? So even this also I have to delete. So delete A. So 2 deleted. So B, A, B, right? B, A, B, and then insert B. So if I am applying all these 3 operations, deletion of A and insertion of B. So I can get this, that is I can transform this x to y, right? So finally the minimal number of operations required are 3. So if you have seen clearly, whenever you are writing the solutions for dynamic programming problems, the final solution will be in your hand priorly, right? So the main theme is to apply the dynamic programming approach in your problem. That is only the theme, right? So here if I am applying these 3 operations, I can transform x to y, right? So now I want to show the solution with the help of this table, right? So C of ij, and here I want to convert this A, B, A, B to B, A, B, B. So what I am supposed to do, right? So here initially what I will be having here B, A, okay. Here I don't have nothing, right? So nothing to nothing, if I want to convert, this is 0, right? So no, because nothing and nothing I am having, so there is no conversion, so 0. And here I am having A, and I want to convert this to null. What I am supposed to do? I have to delete that A. So for deletion I required 1 as a cost. Now here I am having the string as AA, and I want to convert into null. So now 2 deletion operations. Firstly I have to delete this A and next delete this A. So 2, right? So now again A, B I have 3, and here I have null string. So here 3, and here A, B, A. So here 4 characters and here null 4, and here 5 characters and null. So 5 deletion operations, right? So likewise I need to fill up the elements or fill up this particular table. So in order to fill this table, I have a what we can say, I have some tip for you, that is here replace, what we are applying generally, replace, remove or delete and insert, right? So replace, remove and insert, right? So now this is your I and this is your J, for suppose, and if R is not equal to C, that is the row character is not equal to the column character. In that case what I am supposed to do is minimum of this replace character and remove character and insert character, right? Minimum of these 3 plus 1. With this I need to fill up this, right? Whereas if I am having R is equal to C, that is row corresponding to the row value and the column character both are equal, in that case simply copy this diagonal element, okay? Here simply copy diagonal element, understood? So here if I am having if I am reading a different character, so in that case I need to take the minimal of these 3 plus 1, minimal of these 3 plus 1. If I am having similar characters, so in that case just copy the diagonal character, that is enough. So here now in order to fill this, so what I am supposed to do now, here 0, okay, 0, 0, 1, right, and here I am having null string and here I am having B, right, 2 different characters, this is null and this is B, 2 different characters. If I am having 2 different characters, so minimum of these 3 which is 0 plus 1, so which is equal to 1. Now here null string and A, here also the 2 different characters, so minimum of these 3 which is 1 plus 1 which is 2, right, and here also minimum of these 2 which is 2, 2 plus which is 2 plus 1 which is equal to 3, and here minimum of this 4, right. Now here I am reading, okay, A and here it is null, A and null, so which means that here is different one and here is a different one. So in that case what I am supposed to do, here I need to take the minimal one, right, minimal plus 1, so which is 0 plus 1 which is 1. Now here A and B which are 2 different characters, again 0 plus 1 which is 1, and here A and A and A, in this case both are equal, so simply copy this diagonal which is 1, right. Now again here A and B 2 different, again minimal of 1 plus 1 which is 2, and again here minimal of minimal plus 1 which is 2 plus 1 which is equal to 3. So likewise I need to fill up all these things, right. If at all, if you have not remembered, or if at all if you don't have the time to compute all these values with the help of recurrence relations, actually you need to compute all these values with the help of recurrence relation as per DP approach. But if you don't have a sufficient time, when the given string is too large, so in that time you will not have a sufficient time in your main examination. In that case simply you can apply this principle, then it will be done very easily. Now let us see how to solve this, right. So now this is your given recurrence relation and this is your string, this is your table where I need to convert this AABAB to BABB, right. This is X and this is Y. So for that initially cost of I comma j, cost of I comma j is equal to minimal of cost of I minus 1 comma j plus d of xi, right. So here this cost implement function is this one, right. So initially cost of 0 comma 0, what is the value cost of 0 comma 0, which is 0, right, cost of 0 comma 0 is 0, and cost of 0 comma 1, 0 comma 1 which is 0 comma 1 is 1 here. Why? Because cost of 0 comma 0 plus I of y1. So to insert or to delete or to replace all these costs are 1, I am assuming. So cost of 0 comma 0 plus I of y1. Here cost of 0 comma 1, what it mean? Here I is equal to 0 and j is greater than 0. So in that case what I am supposed to do? I have to apply this formula, which is cost of 0 comma j minus 1, which is 0 comma 0. Cost of 0 comma 0 is initially which is 0. So 0 plus 1 which is equal to 1. So I need to fill up this 1, right. So now cost of 0 comma 2, 0 comma 2 means here cost of 0 comma 1 plus I of y2 which is equal to 2. In the same manner I need to find out up to cost of 0 comma 4. So all these values we have filled up 0, 1, 2, 3, 4. Now what is the next step? I need to find out cost of 1 comma 0. Cost of 1 comma 0 means here 1 comma 0. So j is equal to 0. In that case what I have to apply? I have to apply delete operation. So which is cost of I minus 1 comma 0 plus d of xi. So which is cost of 0 comma 0 plus d. So for deletion also I am assuming the cost as 1. So 0 plus 1 which is equal to 1. So here I am filling it with 1 comma 0 which is equal to 1, right. Now what is the next step? I need to find out the next values, which is cost of 1 comma 1. Cost of 1 comma 1. The cost of 1 comma 1 is equal to minimum of cost of 0 comma 1. Here the cost is greater than, okay, here the costs are both are greater than 0. Here I is greater than 1, I is greater than 0 and j is greater than 0. So in that case I need to take cost implement function, right. So here cost of 0 comma 1 plus d of x1, and here cost of 0 comma 0 plus c of x1 y1, and this one. So finally this will be equivalent to 2, right. So even here I can directly give the answer, which is here 0, 1, 1, right? I have 0, 1, 1. So what is the, okay, 0, 1, 1, right? A comma B. So here what is the value? Here what is the minimal value? So that is, okay, that is 1. So here A I want to convert. So here likewise I need to fill up all these values, right? So here this is a formula, okay, here cost of 1 comma 4, even with the same formula cost of x comma y, I need to fill up this. So which is equal to 3. Now in the same manner compute even the remaining values also by using recurrence relation. Otherwise you can apply directly the formula which I have told you now, right, previously. Now finally what is our solution? Cost of 5 comma 4 is the final solution. So what is the cost of 5 comma 4, which is 3. So as I said earlier, 3, basically minimum 3 operations are required to convert x to y. What are the 3 operations? 2 insert operations, 1 delete operation, right? This is the operation. Now, so therefore the minimum number of operations required to convert x to y is equal to. So now this is about string editing problem. So today we have seen how to convert x to y, which is x string to y string with the number of operations, okay, either insert operation or delete operation or a change or replacement operation. And also we have seen how to find the solution directly also, right? And here we are finding the solution in dynamic programming with the help of recurrence relation, as we have seen now. And also we have seen one of the example, right? Now this is a assignment, my dear students. Transform the string program to prolog and transform the string designing to developing, right? Thank you.